Hello guys, welcome back to my channel mathszoneafricanmotives. In this platform we shall be focusing on industrial electronics, that is working on superposition theorem, that is working on network theorems. So I have a question that we are going to actually focus on from this platform, that is on the application of the superposition theorem. So if you're new guys, you can consider subscribing so that you won't miss any of the classes that we shall be having from mathszoneafricanmotives. So the question here is use the superposition method or the superposition theorem to calculate the current flowing through the 8 ohm resistor for the circuit in fig 1 below. All right, so we are asked to apply the superposition theorem, take note, and we've got 10 marks for that. All right, so okay, for the meantime, don't consider these currents, guys. Just don't consider these currents. Okay, I'm going to talk about it. So this is the circuit diagram that we are given in this case. Okay, so what you're going to do when you're answering this question, remember the stages that you have to remove one of the sources here. When you remove one of the sources, you calculate the current that is going to flow through the 8 ohm resistor using the stages of superposition. Okay, so which stages are we talking about? Okay, so let's start in this way. I'm going to remove the first resistor, which is the 8 ohm, which is the voltage of 10 volts. So let's just write solution here. We are going to remove that 10 volt source. So this is a source. Okay, so the moment, so like I said guys, it depends. You can start with this one or you can start with this one, depends with you. Okay, so this is my first step. Okay, so if I remove this source, I want you to see what is going to happen. You are going to remain with this internal resistor here. You're going to have this internal resistor, so that means you are going to replace with 12 ohm resistor. Let's just write this 12 ohm resistor, which is our internal resistor in this case. All right, so let's just leave it like that. So that means your circuit is going to look like this, okay, because this is no longer there. All right, so the presentation here, guys, is just one and the same, like this. I'm just going to put it in a simpler way so that we can actually understand what is happening here. So this resistor here, I've just taken it down to put it here. It's just one and the same thing. Okay, this is our resistor here. Okay, then we've got this resistor of 8 ohms. Let's just put it this way. All right, then here we say because of the internal resistor, we have removed the source, but there is an internal resistance here, so it is going to be like this. You put that internal resistor, so which means you've got 12 ohms here, 8 ohms. All right, then here we've got 5 volts and 10 ohms. So this is our 5 volts here and 10 ohms, like this. All right, so let's just put maybe into consideration also the names of the branches that you're going to work. This is the V1 here. This is our V1. So we are going to take this as our R1. Okay, and because this was V2, so I'm just going to take this as R2. So let me just put this as R2, because I'm not given these, I'm the one who is naming these resistors, so I can name it R1, R2 no matter the way, and this one I'm going to name it R3. So that means here we've got our R3, our R2, and our R1. Okay, so how is the current going to, because what we are focusing is this 8 ohm resistor here, but remember, we can't just calculate the current in the 8 ohm resistor. We have to consider also the circuit, how the current is going to flow, because the current is going to flow from this source going this direction. So which means here we shall have the total current of the source, which is from the one. So you're just going to write it as I1, okay, or just IT, whatever that you want to write. okay, A like this, because this is our first condition A, and it's going to branch in this and branch this. Take note, this is your positive, negative, so the current flows this way. All right, so the current is going to flow in this direction, and this is going to branch here to give us I2 here. So you shall have I2 from the resistor 2 and I3 from the resistor 3 like this. So these are the currents that we can have, but we can't find this I3 because we know that we need to have, in order for us to have I3, we are supposed to first have the supply current so that we can use the current divider rule. So that means we have to find this current first. And we can't find this current because you need the voltage, because remember that the current there is the total voltage over the total resistance of the circuit. So this one is there, but this one is not there. So that means we are forced to calculate the total resistance of the circuit there. So these are the stages that you're supposed to take. Okay, so what is going to be the total resistance? Remember, if you supply here, so this is actually in series, then these two are in parallel, these two. So R1 in series plus, but these two are in parallel, which is R2 and R3. So you're going to multiply. Remember, in parallel, you use product over sum for the resistors in parallel. So it's R3 times R2, that is product R3 times R2 over the sum R3 plus R2 like this. All right. So this is what you're going to have at the end. In this case, guys, what are we going to do? Sorry, we have to take now the resistors and substitute. That is R1, which is 10. So you've got 10 here plus R3 times R2, which is this 8 times 12. Take note, this is 12 there. So it's 8 by 12 like this. Everything over, you add 8 plus 12. All right, so it's 8 plus 12 like this. Now, from the consideration that we have, as you can see, this a combination that is actually taking place here, where you can just use a calculator, you multiply. This is going to give you something like 4,8 from your calculator. So if you add, this is going to give you 14,8 ohms, which is the total resistance of the circuit. So how is this going to help us? Remember, we said the current that is going to flow in I1, which is the total current, the one that you want to use the current divider rule, is V1 over RT1. So that means from this consideration, we can have our I1 in this case, which is the total current, which is V1 over, take note, we are working with the V1 because we want this current. We are not working with the voltage. This one is already removed. The 10 volt is no longer there. So you are working with V1. Take note. So over RTA, which is your V1. In this case, it's 5 over the total resistance that you obtained there, which was 14,8. So this is going to give us this decimal, guys. Okay, let me just adjust this way. You're going to obtain 0.337578. This is 7837 like that. All right, which is going to give us to 3 decimal places. That's 0.338, because this 8 is going to change this 7 into 8 like this. All right, so this is the total current, which is in this case we are representing as I1A, which is representing the total current. It's one and the same thing. Sorry. So now what we need is to apply the current here, to apply the current divider rule, because remember, this current here of 0.338 is flowing here, 0.338 amps. This is the one that is flowing here. So it is the one that is going to branch here and also branch here. So using current divider rule, in order for us to have the current in the 8 ohm, you are going to use the next resistor, this one on top. So it's going to be R2 over the sum of the resistors. Okay, so that means the formula is going to look like this, guys. Okay, remember, this is the current in the 3 ohm resistor according to the order or direction that we have taken. So I'm going to write as R3 I3A is equal to, so using current divider rule there, so it's going to be R2 over R3. So it's R2 over R3 plus, let's just say R2 plus R3, which is one and the same thing, even R3 plus R2. But what is important is that for current divide, you don't use this resistor on top. You use the one that it is parallel to. Then you multiply by the total current, which is the supply current, this one. So we are going to multiply by supply current, which is I1A. So let's just substitute here. So we have I2 in R2 in this case, which is 12. So this is going to be 12 over 12 plus 8. So that's going to be 12 plus 8 times I1, which is in this case 0.338. Alright, so this is what we have, and since this is in amps, definitely our current also is just going to remain in amps there. Okay, so we're going to have 0.2028, yeah, something like that, which is 0.203 amps. Alright, so this is our I3A. So that is the first condition, that when we had to remove the source, which is the 10-volt source. And we calculated the current, and take note also the flow of current is facing downwards. This one, the direction of current, let's just put it this way so that we remember. Now we have to go back to the question again and repeat the same stages, but now we are going to remove V1. This time we are going to remove the other source in this case. All right. So this is our target now. So we have to remove that. So let's just see what you're going to have. When you remove this source, we are going to remain with this resistor here. This is what you're going to remain because it's an internal resistor. So let's just put this aside. Let's hope it is not going to affect us. I hope it is not going to affect us. So we are going to remove this time the 5-volt source. So this is the 5-volt source that we are given, and replace. So you're going to replace with 10 ohm resistor, which is the internal resistance. So it's the 10 ohm resistor like that. So let's see, guys, what is going to. So these are actually some of the typical questions which are interesting in exam, because it's a repetition that you'll be doing if you are to consider this. So let's just remove this source, guys, and see what is going to happen here if we remove this source here. So you're going to be left with the internal resistor. We can just put it this way, it's one and the same thing. Then another resistor inside there, like this. All right, then this one, there's a source and a resistor. So you can just put it this way. No matter the way, guys, you can just put your source here and then the resistor like this. It's one and the same thing though. So it's one and the same thing this way, guys, one and the same thing. So remember I said this is R2, R3 and R1. So you've got R1 there, which is 10 ohms. Remember, your R1 is 10 ohms, your R3 is 8 ohms. So this is R3, which is 8 ohms. We have got the source here from V2. We are now left with V2 this time, which is 10 volts. So this is the one that you're now going to work with, and R2, which is 12 ohms. So take note about this type of a question, guys. You must be very, very careful how you indicate your currents, your resistors, your sources, and so forth. So the idea is still the same. we need the current that is going to be supplying. So this time it is going to flow this way according to the positive and negative. So remember, current from the positive going. So that is the direction that is our current is going to flow. So in this case, this is R2, so we just put this as I2. So since this is our second condition, we just put as I2B, then this will be I3B, and this will be I1 due to the resistor 1 there, be like that. So according to the flow of currents that we are having, this is now the supply current, which is actually the total current that is going to supply this according to Kirchhoff's law, that it is going to branch here and also branch here, and the two, they will come back again and circulate again. So that means we have to calculate the total resistance of the circuit, but considering that this is in series to these two resistors in parallel, so our RT B this time is going to be the series resistor of R2 and the parallel. So it's going to be R2 plus these two now that we are having, these two. So as you can see, these two are in parallel. So whenever you're working with the parallel, it's always about the product over the sum, always product over sum. So you can just find your product over sum, which is R1 and R2 and R3 this time. So it's R1, R3 over R1 plus R3, which is product over sum. So R2, we have our R2, which is the series resistor here of 12 ohms. So that will be 12 ohms there. Okay, so this is our RTB plus the product over sum, which is of these two. So you just multiply there. That's 10 times R1 times R3, 10 times 8 over 10 plus 8. So as you can see, that's the formula that you need mostly. You need this formula mostly. So this is going to give us 12 plus 4,44. So this is going to be 4,44444 and so on. So you just round off to 3 decimal places, which is 4,444. And if you add, you're going to obtain 16,444 ohms like this. All right, is our RTB, which is the total resistance of the circuit that we are going to use to calculate now the total current, which is I2B, which is our total current in this case. So that will be the total current is the take note, V2 is the one that we have, not V1, because this one is removed. We've already removed, so we are left with V2, which is 10 volts. Okay, so it's V2 over the total, so which is 10 volts here, the total, our V2 over the total resistance of 16,444. Okay, so this is going to give us a decimal, which is 0.60812 and so forth, which is 0,608. So if you are to cross check, if you are working from this question and you've seen this from the, take note guys, this is going to be V2, which is this 12 volts, not the other resistor. V2, take note, because you have replaced this, you have removed the other one. So the one that you have removed is no longer part of your circuit. It is not going to work. You work with the one that is on the circuit, which is part of your circuit. Okay, so take note guys, some of the stages that you might have as mistakes from your marking guides and so forth, but this is what you're going to have as the current, which is I2B. So this is actually representing the total current, but this is not what we want. This is not what we want. Us, we need this current specifically in the 8 ohm resistor, which is I3B. So this is the one that you are now going to use the current divider rule. Why? Because we now have this total current, which is 0.608, this one, which is the supply. So we are going to use the current divider rule from R1. Remember your current divider rule, guys. So it's going to be I3B, which is you take the opposite resistor on top, which is R1 over the sum of the resistors. So it's R1 over the sum of the resistors, which is R1 plus R3 times the total current, which is the supply current, which is I2B in this case. This is your supply current, which is the total current. All right. So we have to substitute here our R1, which is 10 over the total, which is 10 plus 8. Okay, this is R3, which is 8. Then this has to multiply the total current, which is the one that we have 0.608, like this. All right, so that's gonna give us if we are to apply our calculator properly, we are going to obtain 0.33777 and so forth, which is 0.338. Suppose this one is going to round off, which is 38 amps. All right, so this is our I3P, and take note this time it's facing this direction, which is actually the same direction as the first one. If we are to consider from the first circuit that we had, remember this is a combination of circuits actually that you're going to work with. So this current, when we remove this source, it's facing downwards. All right, from the first consideration that we did, we calculated I31 in this case, and if you can see, it was facing the same direction. So that means the current in the 8 ohm resistor, which is I3 in this case, which is the current, right, which is the current in the 8 ohm resistor. In the 8 ohm resistor, take note guys, our question is to calculate the current that is going to flow in the 8 ohm resistor. So it is going to be the sum of the two, because they are flowing in the same direction, which is these two currents that we have here. This one was flowing this direction, so you're going to just add them, which is I3A plus I3B, right, which is 0.I3A 0.203 plus the B, which is this one, 0.338. All right, so this is going to be the total current. So guys, it is very, very important that you consider your calculations. You consider your calculations very much. So this is your I3, that's the current which is flowing in the 8 ohm resistor. So the naming of the circuits, the naming of the currents from the circuit that you are given is something that is very, very important. How you separate your circuit, how you remove the circuit to replace the currents, the direction of the currents is very, very important, because it is going to finalize your final answer here, that are you going to take it as a positive or as a negative? Because sometimes another current might face this direction and another current might face this direction, so you have to subtract on a condition like that. You have to subtract, subtract like that. Okay, when they are facing same direction, either like this, they are facing same direction, or they are facing same direction like this, there you have to add. All right, so these are the typical conditions. As you can see here, we have to add because they are facing the same direction. So that will be the current that is flowing in the 8 ohm resistor. So that's it guys, from Maths on African Motives, working on industrial electronics for N4. So if you're new guys, you can consider subscribing so that you won't miss any of the classes that we shall be having from Maths on African Motives. So if you have questions and topics actually under industrial electronics N4 that you want us to work on, you can simply send those questions so that we can work on them on this platform, so that we can all benefit as we prepare ourselves for the exams which are ahead of time. Till we meet again.